All right, let's look at section 10.4, exploration 2, which reads, for what values of x does the series below converge? And the series is x minus x squared over 2 plus x cubed over 3 minus ... And our general term is negative 1 to the n minus 1 times x to the n over n. And part 1 asks us to apply the ratio test to determine the radius of convergence. Now the ratio test says that the limit as n goes to infinity of the a plus 1 order term divided by the nth order term is going to be equal to some value L. And then depending on what L is, we know whether or not the series converges. And for the series to converge, we want L to be less than 1. Now, because our series can have some negative terms, when we apply this, we're going to want to take the absolute value. And we know from one of the other theorems in our chapter that if the series converges absolutely, the original series is going to converge as well. So we're going to have the limit as n goes to infinity of the absolute value of the n plus 1 order term, which is going to be negative 1 to the n plus 1 minus 1 times x to the n plus 1 over n plus 1. And then we're going to divide that by the nth order term, which is going to be negative 1 to the n minus 1 times x to the n over n. And we're taking the absolute value of this whole thing here. Now we really don't need to worry about the negative 1 terms because we are taking the absolute value of this. And as always when we use the ratio test, we can do some canceling. So for instance, all of these x to the n terms down here are going to cancel with the x to the n terms up there. So we're going to end up with the limit as n goes to infinity of the absolute value of x over n plus 1 divided by 1 over n. And as we all know, the denominator of a denominator is going to be a numerator. So this is going to be the limit as n goes to infinity of the absolute value of n over n plus 1 times x. And then if we apply n behavior modeling here, we're going to have basically n over n, which is going to cancel, and then our limit is no longer going to be a function of n. So it's just going to be equal to the absolute value of x, which is going to be equal to L. And as we said earlier, we want L to be less than 1. So we're going to say that the absolute value of x is going to be less than 1. And when we compare that with our formula for determining radius of convergence, which is going to be x minus a is less than r, this is going to tell us that r is going to be equal to 1. Now we'll do the rest of the parts of exploration 2 in separate videos.